My name is Viswanathan. I go as Venkat. I'm working for AWS as a partner solution architect. Been with the company for more than a year. And I'm a dedicated partner solution architect for Databricks, so I'm supporting them. And I work with their, on many product integration. In today's speaking session, I'm going to talk about IoT, how Kinesis is integrated with the Databricks, and some of the nice features that we built for getting the data at scale. That's what I'm going to discuss. With that, the agenda is going to be, let's start with what is streaming, right? And then some of the challenges we have with the streaming, and how AWS technologies and Databricks, with the combination of those two, how we can mitigate those problems and to build a robust, high-performance systems. So what is streaming? Streaming is a continuous flow of data from hundreds and thousands of systems or applications into other hundreds and thousands of applications, right? So if you really look at just the credit card alone, back in 2020, it is estimated that more than 1 billion transactions occurred per day across the world. So that is the scale that we see with the streaming. It is not just credit card, we also see multiple applications, multiple industries are leveraging streaming as an option for doing real-time, near real-time insights for better customer experience. And so some of the use cases that we see in the industry is, the number one is real-time anomaly and fraud detection. It is not just for financial services. This is also across the industry, right? The fraud detection can occur multiple things, and the other thing is we want to give you a customer experience, the personalized customer experience. For example, if the customer is trying to log in and you want somebody is trying to the email login, you immediately get a security threat, and so what is going on, right? That kind of experience the real-time streaming provides. And the other one is now, earlier typically the applications were monolithic applications, right? You get the data, you you run it. Probably you are going to run this multiple times in a day or as a batch process. But today, we want to do a real time. So everything you want to do it in a as it comes, you want to get the result. So from monolithic applications, we're moving to real-time applications. So streaming does provide the opportunity for you to build a real-time, near real-time applications. I personally have experience in the healthcare industry. As you get the claims and you want to process the claims, earlier it used to take days, and now it takes just minutes with this microservice-based architecture where you decouple and you use streaming as a platform to move from one process to another process. So this comes with the challenges, right? One is streaming is difficult to set up. Whether you are running the streaming just for a small application, or you are building for hundreds and thousands of systems, the underlying architecture to build streaming is going to take the same amount of effort. So difficult to set up, and that leads to basically it's expensive to maintain. You need more people to manage your infrastructure, your storage, your the computing, and so on. And with that, also now with the data privacy rules, and you want to do it at a global scale, you're going to see that you need to have some privacy concern data policy governance around streaming also, and it can vary from one country to another country. So this talks about the overall many facets of how the streaming. So from source to destination, you have hundreds and thousands of source applications emitting data, and you need a system to collect the data, it's a stream ingestion, and then you need to store the data, finally you process, and then push it to destination. So everything has got challenges, and you need a system that can easily do this work with the least amount of manpower to deal with. So this is where Amazon Kinesis comes into picture. Amazon Kinesis is built for streaming applications, where you can continuously ingest data to Kinesis and then do analytics inside the Kinesis family. At the same time, I have the flexibility to use multiple other systems to process as well. So you get both flexibility. So Kinesis family has got Kinesis data streams, Kinesis data firehose, and Kinesis data analytics. So Kinesis data streams is mainly for ingesting data into Kinesis, and then firehose is where the data you can process, or you can send it to multiple third-party applications, or like multiple native services. So it has got Lambda you can use, or you can send it to like S3, or you can do transformation before sending data to different systems. So Kinesis Data Firehose is specialized for that. Or you want to do inbuilt real-time analytics, you can also do with Kinesis. It has got a notebook feature. It's got SQL as well. So Kinesis data stream is an anchor for data streaming. Yeah. So this is just a, yeah. So you have, in Kinesis, you have flexible stream storage. What it means is, suppose you want to, like as you get the data, you may want to store the data for 1 day, or you may, for complaints purpose, you may want to store the data for 365 days. Yes, you can do that with Kinesis. You have the option to customize how long you want to retain the data. So that is there. So up to 1 year you can retain this data, and the data is maintained in a specific order. And the other one is, as you ingest the data, generally you have multiple consumers reading the data. Typically what happens is the throughput channel is shared by multiple consumers, so you may not get the optimum result. But with enhanced fan out, each consumer can get a dedicated throughput of up to 2 MB per second. So as the data comes in to this Kinesis, you can consume the 100% the same flow from the consumers. So these are all it's a data consumer option. As you can see, like Kinesis and Databricks has got a connector. You can easily consume data from Kinesis. I'm going to show the demo where we can see this. And this just talks about how the standard consumers versus enhanced fan-out consumers. Yeah, this is the data consumer options. So you can see the Databricks is is one of the consumer. And here we see the standard consumers and enhanced fan-out consumers. What is the difference? So you can see that the standard consumers, the throughput is shared by multiple consumers. If you have, let's say if you have 4 consumers, then 2 MB data throughput will be shared by 4 people, so you're not going to get the 2 MB. Whereas if you go with enhanced fan-out, you are going to get the complete 2 MB. Up to 20 consumers you can configure with enhanced fan-out. Now, the Databricks has got, it is, as you know, like a Databricks Lakehouse platform. It is a one-stop shop for doing from data engineering through all the way, machine learning, data analytics and machine learning. So, so with the combination of Databricks and AWS system, we can build the real-time analytics. I'm going to show the demo of how we can use the Databricks for this purpose. And this talks about the Databricks on AWS reference architecture. So the demo is going to be on streaming data comes to AWS IoT events, and then you're using Kinesis to consume the data from Kinesis to get the data from IoT events, and then Databricks will be used to pull the data from Kinesis and do the processing, and finally it's going to write the data into Delta Lake, which is stored in S3. But there are other things that you can see, like we support multiple systems like QuickSight, MSK, or wealth of AWS services that you can see, and right from Graviton processor to all the way high-scale, high-end services, pretty much we have tight integration between AWS and Databricks. And the demo, as I mentioned here, like you can see that IoT device simulator is, again, like it is a Amazon built IoT simulator. It comes at no cost, and you just pay for underlying services, and that you can use to generate hundreds and thousands of sensor data. You can simulate and you can run, and that goes to IoT core, and then from IoT core we configure and push it to Kinesis data streams, and then from there, the Databricks will be consuming the data. That is the demo we are going to show. With that, I will just go to the demo. While I'm doing that, if you have any question, please, you can ask me. So you start with, you go to IoT device simulator, and there is a launch in console. So when you do the launch in console, what it is going to do is, it is going to create a CloudFormation stack for you. And you can, before you deploy this, you need to change. If you don't want to do it in East 1, select the region you want to put the simulator. Then once you do that, I already have the simulator running. So let me just go here. I am running it on US East 2. So you can see that there is a device simulator running. So it is successfully installed. CloudFormation has done it. Then if you go to outputs, you will see that there is a console URL. Like, you just clicking on that. Sorry. So there is a simulator that I will show a little later. That's going to give you the option to declare device types, and you can see the data. And then you go to IoT core. Just hang in. I'm just closing this. Sorry. not able to do this. Can somebody help me? I just need to turn off the monitor. Can you please help me? Just a minute. It's going to be a beautiful demo. Yeah, you can put it back. Okay, you can see that how the IoT device simulator is. This is the console where you can see that we declare device types. So I already declared device types here. So here I call it device 10, device 1 to 10. Like I have multiple devices, and this is the structure of the payload we have. Right? From energy, this wind turbine is what I'm doing. It's energy is calculated, and it is going to give from sensor A through F, and what is the timestamp, and then what is the turbine ID. So it is simulating 10 devices, and the way I run the simulation is just add simulation, and you can put how many devices you want. Like you can keep adding all the devices, and give the simulation name, and then it's what frequency you want to run, right? Whether you want to run it for a second every second, or you want to do it every X seconds, you can declare here, and how long you want to run this. So if you say, like, for example, I want to run this for 1 hour, I put 3,600 seconds, and then it's going to run every second. It's going to generate for every sensor device is going to generate data. And for 1 hour, it is going to run, and then after that, it is going to stop. So I already built this one. There's a one here. And you can see that there's a start simulation, stop. So I do start. And then when I go to view, so you can see that the data is getting generated, right? So it's going to do it for multiple devices. So that is how the data is coming. And then this data gets pushed to IoT core. So IoT core, the way it gets pushed is, if you go back to this device simulator, there is something called, like, each device, you have a topic here. So demo, in this case, I have a topic. So all devices, I put the same topic. But so you can have multiple devices running multiple topics. So for our example, like in IoT, I go to message routing, go to rules, and here you need to provide the SQL statement, which is select star from that topic. So IoT device is going to, the simulator is going to push the data to IoT core automatically. Now the data is already there. Now you're just sitting there routing for how to push this topic to Kinesis. And here you can give the action as Kinesis stream, and then which Kinesis stream the data is going to go to. That is the stream name. That is, I already set this stream name, and that is where the data is going to go with a partition key. You can specify whatever partition key you want. That partition key will be used for sharding purpose. So I'm just using the standard unique identifier here. That's what we do. Like just to give you like create rule, give the rule name and rule description. Let's say it's a demo. Go to next and give the SQL statement. You need to change the SQL statement. Go to next. Okay. I need to give the right SQL statement here. Let me copy this. Go here. Demo. I'm giving here the next, and then here you specify the action. So you can see that you can push the data from IoT device simulator to IoT core. From IoT core, you can push the data to multiple things. See here we are going to do Kinesis stream. You can also do Kafka and so on, right? So you have other options. So once the data is pushed to Kinesis, and you can also monitor, IoT, you can also monitor the way the data is, whether data is coming here. So you will find that the data is coming from IoT device simulator to the IoT core. So now let's go to Kinesis. So Kinesis, it is so easy to create Kinesis data stream. Just give the name of the configuration and select whether you want to on-demand or provisioned. So generally for real-time streaming, we recommend on-demand, or if you know how the workload is going to be for you, like then you can go with provisioned. But on-demand is flexible for you, right? So you can do that, and you do get write capacity 200 MB per second. Read capacity is 400 MB per second. So for consumers, so for every ingestion up to 2 consumers, it can support. But if you want to go beyond 2 consumers, you have multiple consumers, then go with EFO so that you get a dedicated throughput, right? Then, so let's go back to the one I already have. So you can see that there's applications here. There's a producers, right? You have multiple producers can ingest the data. In our case, we are using simulator to IoT core. But you can use you can even use Cloud Shell or like Cloud9, create your own Python and ingest data, or you can use Java-based SDK and so on. Like that, consumer also you have multiple options. So Kinesis family itself has got some of the options, and Databricks is one of the consumers as well. And you can see how the data is flowing by going to the monitoring. It will show after some time. I need to do 1 hour, or maybe I can even set last 15 minutes or so, like last 15 minutes or 1 minute. So you can start seeing the data flowing. Let's come back to that, and this is a configuration. This is a data stream capacity, on demand, what is the write capacity, read capacity, and then the data viewer, you can see by default it comes with 4 shards. So you can see the get records. So you can see the data is coming, right? So this is the data we are generating from the IoT device simulator. So now that we know the data is getting, now let's move to the Databricks. So here we can see that, yeah, we can see that there is a okay. So here you can see that we have created. So there is a platform here. So data ingestion. The data ingestion. This is the ingest from bronze, right? So you can see that we specify the access key, and then this is where we set the EFO, like enhanced fan out configuration for database. So this is Scala program. So what it does is it is registering the stream name, and this is going to, in Kinesis, it is going to set this as a, okay, this Databricks is using enhanced fan out, right? And then the Python program is a PySpark. It's going to do a sensor data. It's going to continuously get the data from Kinesis. I'm not going in the details, but if you look at the schema, the same schema that we used in the simulator, the same schema is now we define here. And then read stream format is Kinesis, and with column, and so we get the data, right? So then the next one is, as this is going to continuously get the data, then we have a couple more we have there is a SQL based one. So here we have few additional data like turbine data, which is a master data for all the turbine sensors, and then there is a history of the status of each turbine, when did it fail, when those information. So that we get and we put it in a Delta Lake, and once we do that on an hourly basis, we compute the aggregates on an hourly basis using the sensor data that we get from Kinesis. We aggregate the hourly, and then once we do that, we use this data for doing a predictive modeling. So if you look at here, there is a model is already pre-built. So we are using a UDF to make this model callable within SQL. That's what we do, and then you get this data is also stored in turbine current status. So in here, what we are doing is we are using Delta Live Table. So Delta Live Table is a declarative way of running your workflow. So by defining here, there are two things we do here: create incremental live table, and which means it is a streaming data. That is what we are using for incremental live table. So we are saying that this is going to be a continuous one, and the live table is something that we do aggregate every hour, which is it's a materialist data. So that's the difference, right? And we can also specify the constraints. As the data we get, what kind of constraints we want to do it. So here we are just saying that, okay, expect this, but you don't do any action. But if you want to take any action on the data quality, such as you don't want to process this data, you can also say drop row, or drop row and continue, or you can even stop. So that option is there. And it comes with you have the comment. So these comments you can see it in when we do workflow, we can see that as well. In here, you can see that constraint is we have turbine ID should be valid. If not valid, then if it is not null, then if it is null, then by drop row. That's what we do, right? Most of the time we do that. And then yeah, that pretty much this one. And one other thing is in the Delta Live Table, when we are going to go to the workflow where we declare Delta Live Table. The Delta Live Table has got if you are running a Python program, you need to keep this Python PySpark in a separate notebook, SQL in a separate notebook. You cannot combine Delta Live Tables in a single one, just like regular notebooks. That is how it is designed. And then that is the reason why we have a separate one for the UDF. Since it is a Python, so we need to keep a separate one here. And we will go to the workflow. And you can see that there is a, this is where we have a Delta Live table running. So the way we configure Delta Live table, before I do this, I can just show create pipeline, right? Create pipeline. Give the name of the pipeline as a demo, for example, and then whether you want to run this in triggered or continuous. Since we are running, streaming data on a continuous basis, we have to declare continuous. Otherwise, it's going to say that it fails, right? And then source code, just go here and select the source code. Right? I can go and select the source code. And it said Lakehouse IoT platform and data ingestion. So I select one by one. I put ingest, I put DLT, turbine, and DLT. So once we put these three, and then you can declare your target schema. If you don't declare your target schema, this data will not be visible. It will create, it will generate data, but it will not have a schema representation for you. You need to declare your database, to store the data, so you can use SQL, SQL to query the data, from outside the notebook. And then you can define the configuration as needed. Yeah, then once you save it, what you will see here is something like this. It's going to auto-populate. It is going to know that, okay, how the dependency based on the notebook operation, Databricks, the Delta Live table knows, okay, this is how the flow of information going through, right? So here, the Kinesis sensor data is what we get. It is continuous streaming, and sensor hourly is reading data from Kinesis, right? And then it also gets data from turbine and historical information, right? This turbine current status. So it is getting data from 3 different locations and turbine training. So you can also see, if you go here, how many records are inserted, how many are dropped, and what is the schema. So you can keep, you don't even need to go through notebook or anything. You can just come here and see how the data is flowing. If there are any errors, it is going to show the error. And the way it stores, you can see that these are all the failed runs, right? So when there is some failed run, you can always go and take a look at. But once it is set up correctly, you will not see any type of errors. So mostly it is going to go. I have not come across any problem. So it is generally during setting up is where you find some kind of errors, right? So that's what we do with this, and you can also see this data once it is created. Then we can see the dashboards. You can see that it's giving you some information about how the turbine is running, so you can see that, it is what is a maintenance part analysis. So with this, from device simulator, we can simulate your manufacturing or any of those, real-time streaming, how it is running, so end-to-end without even spending money on actual physical devices. It is going to take just, few hours to few days. You can set this up and do a POC. And Databricks also, I use this whole solution using Databricks DB demos. I just install the DB demos and then make fewer modifications, like ingesting data from Kinesis, and then run a Delta Live table. So Databricks has got the solutions accelerators and DB demos that you can use with a combination of making a few changes and make it work for your use cases. With that, this demo is over. So any questions? I'm sorry for for the initial hiccup. Thanks for. I will. Yeah, please ask the moderator. And Yanis, please feel free to jump in and answer questions.
Okay. Excuse me, I saw that in your example you're using create incremental live table, but the incremental live table is already deprecated 1.5 years ago, right?
Sorry, can you repeat that?
You in your example you create a live table,
Yeah.
which using the incremental live table. The incremental syntax is already deprecated 1.5 years ago. Should be using streaming.
Yes. Yeah, you can give it to him. See, Yanis is from Databricks,
It's called streaming, right? But it is simply a better naming, actually.
Yeah. Did it?
One of the architecture diagrams that he had had QuickSight connected through either Athena via Glue or through Redshift to connect to a data lake. Is there a way to directly query the data lake?
QuickSight, you can directly query the data. Let me see if I can. Maybe we have a booth. Please stop by. We have a dedicated. So you can directly connect from QuickSight to Databricks using JDBC. There are both Spice and direct query. Both are supported. And so it continuously is going to, you can run. Of course, QuickSight, it does not have like a real-time kind of thing, but in 1 minute refresh is there, so you can do that with
have you noticed any significant performance differences going via Athena versus directly connecting to Databricks?
Definitely, right? It's a Databricks Lakehouse platform. It has got inbuilt optimization, right? And it has got Photon, and so the Athena versus Database. Yeah, maybe
I mean, the advantage of connecting directly to DB-SQL is you essentially using the underlying of DB-SQL directly, right? So and all optimizations that the engine has, right? So especially running Photon. Which is essentially the implementation of the Spark engines actually in C++. Right? So you have enormous performance boost. Okay, so and that was actually the one of the main reasons for the integration, right? To leverage the performances offered actually by the DB-SQL engines, right? SQL engines. So you connect directly essentially to the SQL endpoint of Databricks.
Okay, for any other questions, please feel free to reach out to us in the booth. We are happy to, we have got dedicated team.
We're out of time for further questions, but thank you for the talk. This is a great talk.